Welcome to the lesson, The Atom. In this lesson, you are going to explore the parts of the atom. The vocabulary words for this lesson are atom, proton, neutron, electron, nucleus, electron cloud, atomic number, and mass number. Atomic number is the number of protons in the nucleus of an atom. The atomic number is the same for all atoms of an element. The mass number is the sum of the numbers of protons and neutrons in the nucleus of an atom. Are both diamond and graphite made only of carbon atoms? What do you think? Click on the answer to see if you are correct. You got it! It's true that a diamond and graphite look and act very differently, but they're both made of only carbon atoms. Diamonds are extremely hard. Graphite is relatively soft. So what do you think causes them to have such different properties? It's because the carbon atoms are arranged differently in graphite than they are in a diamond. Same atoms, but different bonded structure. Now let's move on and explore this concept more. An atom is the smallest unit of an element that still has all of the chemical properties of that element. With an atom being so incredibly tiny, how did we learn so much about its structure? Years of hard work by numerous scientists. Drag the slider on the timeline to learn more. Ancient Greek philosophers such as Democritus coined the term atom. They said that all matter is made up of these tiny particles. Because atom means undividable or uncuttable in Greek, these philosophers were simply asserting that the smallest particle was something that was called an atom. All these years later, we still use the Greek word atom as the name for the smallest particle of elements. John Dalton describes atoms as solid spherical balls. His atomic theory says that atoms are the smallest unit of an element. It also states that all atoms for a particular element are identical. Dalton also says that atoms of different elements have different weight. Dalton's atomic theory says that atoms combine to form compounds. His atomic theory begins to describe how atoms can relate to each other. Through experimentation, J.J. Thomson actually shows that electrons are indeed distinct negatively charged units of electricity. Ernest Ernest Rutherford finds that atoms have a very dense, small nucleus, but is surrounded by an electron cloud that has mostly empty space. Rutherford discovers the proton, a positively charged particle found in the nucleus of all atoms. He also predicts the existence of a neutral charged particle called a neutron. An atomic model made by Niels Bohr shows the nucleus made up of neutrons and protons surrounded by electrons orbiting in circular paths. The circular orbits will later be shown to be inaccurate. Though not totally accurate, this model is sometimes used today as a simplified model. Work by Werner Heisenberg and Erwin Schrödinger leads to the modern atomic model, the electron cloud model. In the modern atomic model, the nucleus is made up of protons and neutrons. Electrons move around the nucleus in clouds rather than in distinct orbits. Click on the part of an atom to learn more about it. The nucleus is a very dense, very small center of the atom. It contains the protons and neutrons. A neutron has a neutral charge and is found in the atom's nucleus. The number of neutrons plus protons is equal to mass number. The number of neutrons plus protons was equal to mass number. An electron, however, has a negative charge. It is found in the electron cloud outside of the nucleus. The proton has a positive charge and is found in the atom's nucleus. An atom's number of protons is its atomic number. Two of the most important things that you can know about an atom are its atomic number and its mass number. But what are they? Click the pictures to learn more. An atom's atomic number is the number of protons in its nucleus. The number of protons an atom has is important since it determines the element of an atom. An atom's mass number is the number of protons and neutrons it has in its nucleus. Most atoms have the same number of protons and neutrons. However, some atoms of each element have more neutrons than protons. They are called isotopes. Label the parts of this modern atomic model. Drag the labels to the correct part of the diagram. You've got it! An atom contains positive protons and neutral neutrons in its central nucleus. Negative electrons travel within electron clouds outside of the atom's nucleus. Electrons are always in motion. Atoms are mostly empty space. Our current atomic model says that electrons are found in electron clouds outside of the atom's nucleus. Have you ever passed through a rain cloud in an airplane? If so, you know that it's made up of mostly empty space. The same is true with the electron cloud. The cloud represents the area where an electron might be found around the nucleus. We cannot predict exactly where an electron is at any given time, but we know that it's likely to be found in a region represented by a negatively charged state. The area where the electrons are is very large. However, an electron takes up very little space in the electron cloud. Do these atoms have the same atomic number? Click yes or no. 1, 2, 3, 4, 5, 6 protons. 1, 2, 3, 5, 6 protons. That's it. You know that the atomic number comes from the number of protons, right? So if these atoms have the same number of protons, they also have the same atomic number, which is 6. So how has the understanding of an atom changed over time? We've seen the various models from Niels Bohr's model all the way back to John Dalton's model, which was a solid sphere. Now we have the electron cloud model with protons and neutrons in the center or nucleus and electrons surrounding that nucleus. And atoms are made mostly of empty space. You've learned a lot about atoms. Before we finish, let's take a quick look at the main points you've covered. An atom is the smallest unit of an element. Our understanding of atoms has changed over time. Through numerous scientists, atoms are made up of subatomic particles, protons, neutrons, and electrons. Protons and neutrons are found in an atom's small, dense central nucleus. Negatively charged electrons are found in the electron cloud outside of the nucleus. Now that you've finished this lesson, you can click the menu button to exit.